Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend.
So cute. Hi, everyone. I am Dr. Moiya McTier, an astrophysicist, a folklorist, and definitely a friend to the universe, but also a friend to my co-host.
Yes, that's true. I'm Corinne Caputo. I'm a friend to Moiya here and a friend to all our listeners. And I only bring friends to this national park that's a secret to everyone but me.
The secret Corinne National Park, yeah. I feel very flattered. I'm honored to see this space. Since no one else has been here before, Corinne, except for your close personal friends, what's it like?
Well, this is Acadia National Park. It is home to many wildlife and beautiful sights, and it is one of the most beautiful places ever. There's ocean, there's rocks and trees and birds and sand, and it rocks here.
Wait, there's ocean? What state are we in?
Maine!
Oh, so lovely.
It's so pretty. It's one of they're all good, but this feels like one of the best.
I wasn't paying attention when we boarded our transport machine. I'm sorry.
No, that is the best way to travel, I think, is to not fully know what's going on.
Agreed. Any particular reason we are talking today in the national park?
Well, we are talking today at the national park because we're doing an episode on Earth. We all know it and love it. And it's time to celebrate what makes Earth great.
So true.
And one of those things is nature.
Very true. We're sitting on the Earth. We are surrounded by Earth. We're floating on the Earth through space. And so many people forget to think about Earth as a planet.
Yeah.
And since we've covered the other planets in the solar system, I wanted to do the same for Earth so that people remember, no, we're not special. We are all space.
Yes, exactly. It's I do think that will hammer the point home.
Good. Any questions you have about Earth before we get started? I mean, of all the planets that we've covered, it's the one you're most familiar with.
And I feel like it's the one we have the most information about. There's so much I don't know about Earth. Maybe it's a survival mechanism, but just I know enough to survive. And that's it. But yeah, nothing's jumping out right now. I'm excited to hear about it in the context of our other planet episodes, like its mass and diameter and whatnot.
Yes, the numbies, the characteristics for the planet. I have those, and I think it'll be good to give you values in terms of like kilograms and kilometers, because so far, for all the other planets, I've given you the size of Uranus or whatever in terms of how big it is compared to Earth.
Yes.
So this will give you, the absolute number to calibrate all of those relative numbers.
Yes, I love it.
But before we get to the numbies, I do want to talk a bit, obviously not about the discovery of Earth. We didn't have to discover that like we did the other planets, but about what people thought Earth was, because that has gone on a journey. And when you look at folklore from around the world, you can see some similarities and a lot of differences with how people imagine their place in the cosmos. So I have a few examples here from some of the known mythologies, starting with Greek. Do you know who the Greek deity of the Earth is?
I don't think I do, but I think it's a name I will recognize.
You will recognize it. And I will say that there are many deities who are associated with the Earth, right? Like there's Demeter, who is the goddess of the crops in the fields, and there are other agricultural deities for sure, but there is a figure in Greek mythology who is the actual Earth, who is the actual manifestation of the Earth, and that's Gaia.
Oh, yes, I know that.
Yeah, if you've ever been with some like hippy-dippy spiritual people, like they're talking about Gaia and the Earth Mother and all of that. And I love Gaia as a figure from mythology because it's not that she was a goddess who oversaw the Earth. No, she was the Earth. She was the world. She was the first being to come into creation out of chaos early when the universe started, according to Greek cosmology. And then Gaia formed all of the other beings. She birthed Ouranos, who was the sky, who was her son, but also then became her husband because together they had all of the Titans. I really like how you can see the right order of things in Greek mythology, where you have darkness and chaos, and then the earth forms, and then the sky forms because of the earth. That's what actually happened, right? We had an earth. It was spewing out all of these gases from inside, and its own gravity got those gases to stick and form an atmosphere, and that was our sky. And then Gaia also was the ancestor to all of the nymphs and the water spirits and like everything, which I love.
Yeah, I love that. This has just made me think that Earth is the coolest and has has everything interesting.
Yes, from our human perspective, for sure. It has all the things we want and need. Another favorite mythological category of mine when it comes to Earth creation is Earth diver myths. Have you ever heard of those?
No, I don't know what that is. Is it about, like, the oceans?
Yeah. So this is a whole class of myth, and you see it in different parts of the world. It's really prevalent, especially in Native American folklore, with myths of the great turtle, why North America is called Turtle Island by many of the tribes here. And it's also in other parts of the world. But the piece of folklore that connects all of them is the idea that the Earth's land, at least, was formed when an animal dove down deep into the ocean and gathered mud from the bottom and then brought it up to the surface, and it magically expanded.
I love that.
And you see that in a lot of Native American myths where different animals, sometimes like a muskrat, sometimes a frog, went down and collected the mud and then smeared it on a turtle's back.
Yeah, that's so fun.
Yeah, it is really fun. But I think that the Norse myths are also very fun. Are you familiar with like Norse creation myths at all?
I only know Norse stuff like through maybe television things I've passively consumed. It was never one of my like key interests, but a kid I nannied was obsessed with them, so I would kind of read over her shoulder a little bit.
I love that vicarious learning.
Yeah.
And maybe some like Marvel stuff that you've seen.
Oh, yeah. That's exactly like Thor, which I think is Norse.
Yes, yeah. Thor and Loki and Valkyrie, that's all Norse mythology, although the Marvel versions are definitely not true to myth, I would say.
Yeah,
not
that
always,
makes sense.
But yeah, it gives people a good approximation. So I really love the Norse creation myth because to me it does seem like a really good fictionalized version of what actually happened. As an astrophysicist who's studied planet habitability and spends a lot of time thinking about the habitable zone. According to Norse mythology, Midgard, the world of humans, formed in their mythological habitable zone, which I love and I will explain.
Oh, love that. Yes, please tell me.
So they have 9 different worlds in Norse mythology, and it's unclear if that means planet or if it's more like a fantasy realm, because especially back before people were traveling around the world and they even knew that it was round, they used words like planet and world and universe like kind of interchangeably because their local place was their whole world. And so they had 9 of these different worlds, and different types of creatures lived on each of them. There was a world for humans, which was Midgard. There was a world for the Aesir gods, like Thor and Odin, and that was called Asgard. And then there were 7 others. But the world of Midgard didn't always exist. It was created from the body of the first primordial being that was created or came to life in Norse mythology. And that being was named Ymir, Y-M-I-R. And Ymir was a giant who had both male and female parts, and so reproduced within their own body and produced some other beings. Like all of the beings in Norse mythology are descended from Ymir. And Ymir themselves came into being right between the worlds of Muspelheim, which was a world of fire where like fire elves lived, and the world of Niflheim, which is a world of ice. So Ymir formed right in the middle of fire and ice, and that's exactly what the habitable zone is around a star. It's between the places where the star's power is too strong and it will burn you, and where the star's power is too weak and you'll be too cold. So that's a nice little kernel of truth there.
Yeah, fun. I like that habitable zone.
Me too. What happens next is a little bit less fun. Ymir is killed, is
Cool.
slaughtered, and then their body is used to make Midgard. And there are competing sources, so it's unclear to me exactly how Ymir's body was used to make the world, but I do have a quote from a poem, which in itself seems kind of contradictory, but I'm going to read you the poem. It's from a section of the Eddas, although I should say that the Eddas can't totally be taken at face value because they were transcribed, or they were written down by Christian missionaries, Christian monks who heard these stories from the Norse folk. So, take this with a grain of salt.
Mm-hmm. Noted.
But I have this poem from the Eddas that says, "From Ymir's flesh the earth was created, and from his sweat, or in some versions blood, the sea, mountains from bone, trees from hair, and from his skull the sky." But then later on, there's a stanza that says, "And from his eyebrows the blithe gods made Midgard." So now they're saying it's not that his whole body was used to make the world, but just his eyebrows. So from his eyebrows the blithe gods made Midgard, home of the sons of men, and from his brains they sculpted the grim clouds. So no matter how much they're using to make Midgard versus the other worlds, they're still using Ymir in some way, and that is how the ancient Norse folks, that's how they said we got the Earth. That's what they thought the Earth was. So we've come really far.
I like using an eyebrow. I think the eyebrows are fun. It's the piece I'd be willing to give up, I think.
But is that the first piece you would use if you had to make a planet out of someone's body?
No way. But I guess maybe if I didn't care about it, if I was like, here's an eyebrow, have fun.
Like, here, damn, I did it.
Yeah. Yeah.
Yeah, so there are all these ways that different cultures around the world conceived the universe and our planet's place in it, but so many of them were similar in that they understood there was an Earth, there was this thing that we lived on that was somehow separate from the sky, and most of them also understood that the sky part that is our atmosphere with clouds and where all the weather is, most of them understood that that was separate from the cosmos beyond. So there was always this tiered system of understanding, and over the last 400 years, we've really advanced in our appreciation for how those tiers are connected.
Yeah, for sure.
It did take us a while to realize that Earth was a planet, just like, the wandering stars that they were seeing, the Mars, the Jupiter, the Saturn. It took us a long time, in part because we didn't have a definition for what a planet was, and it changed a lot. Like, that was a really hand-wavy term, planet. But we get the word planet from the Greek word planeton, which meant wanderer, because they were calling them wanderers after the Babylonians had their wandering stars, which were the sun, the moon, Mercury, Venus, Mars, Jupiter, Saturn. There were 7 of them. I did just name 7 things, right?
Yeah, I think so. I think you did. I think I heard 7 there.
Okay, thanks. So that's where we get the word planet. And they were just calling them planets because that's what they had always been called. But as we developed telescopes and we started seeing more things out in space, we had to decide if those were also planets. And for a while, we said yes. So everything that we discovered out there in our system, we called it a planet. When we discovered the first non-visible thing going around the sun, that happened to be the planet Uranus, discovered in 1781 by William Herschel. They were like, okay, that's a planet, because it's not a star.
Yeah,
right?
yeah.
So it must be a planet. We had these 2 really big categories back then, and the centuries since have been about splitting those categories into smaller and smaller things that we can define. So we found the first new planet 170 years after the telescope was invented, and the word was used to refer to anything that orbited in our neighborhood. So it included asteroids, it included other satellites, like the moon. It was called the moon, but that wasn't seen to be its own distinct category. Right. Even when Galileo saw the moons around Jupiter, he didn't understand them as moons separate from planets. He called them little stars, which is what people called the outer planets in the solar system. So there was always this confusion. And it got really messy, and it stayed messy for hundreds of years until 2006.
That is so recent. That can't be right.
Yes, I double-checked. I triple-checked. It was 2006. This is when we get our first formal, agreed-upon definition of the word planet. It happened in Prague at the International Astronomical Union's General Assembly meeting. And the catalyst for this whole conversation was the discovery of a rocky body called, well, when they discovered it, actually, they called it Xena. Like, yes, for the warrior princess. Because it was 2005 that it was discovered, January 5th, 2005. And Xena was hot. Xena was big.
Yes,
like, it was
I
the
remember
moment.
that. I remember wanting to watch it, but I felt like I wasn't allowed for some reason. It was off limits.
Oh.
But it might have just been that television was off limits and not that.
Okay. That makes sense. Yeah, I actually just rewatched Xena earlier this year, and I gotta say, I'm pretty sure it holds up. Most of it.
That's really good news. That's so rare.
Mm-hmm. Yeah, so if you still haven't seen it, I think now's a good time, Corinne.
I'm putting it on the list right now.
Oh, I love that. So they discovered this rocky body that they called Xena in early 2005, and it was about a fifth the size of the Earth, which makes it a little bit smaller than our moon, and it orbited out beyond Neptune. And this started, I guess, a dramatic domino effect, because people had lived with our solar system having 9 planets for decades. Let me quickly look up when we discovered Pluto. I want to say in the 30s. February 18th, 1930.
Whoa, right there.
Love my brain sometimes.
Yes.
We had been saying that there were 9 planets in the solar system for almost 100 years, for over 70 years. And we didn't want to add one. People had the mnemonics, right? We also understood that if we added this rocky body and we continued to find more, we would have to also add them to the list of planets in our solar system. And I think there was this fear of inflating that list beyond what most people could easily memorize and, like, retain. But I think there was also this need to set a clear delineation between planet stuff and small solar system objects, here and in other systems throughout the universe. So on August 16th, 2006, the International Astronomical Union circulated a new proposed definition of the word planet. This is a year and a half after Xena was discovered, and people are still in a tizzy. And then 8 days later, on August 24th, 2006, they were in Prague at the General Assembly meeting when the IAU had all of the members present vote on the planet definition. And that definition said that a planet had to be, 1, in orbit around the sun. That makes sense. 2, it has to be round, so its own gravity has to be enough to confine it to a spherical shape. And 3, it has to have cleared the zone around its orbit. That's a direct quote. And I think that is the one that a lot of people take issue with because it's a little bit ambiguous. It's a little bit left up to your subjective interpretation of whether it's cleared out its orbit.
Yeah.
But that is the one that knocked Pluto down.
Oh, right. We talked about this.
Yes. Pluto is round. Pluto orbits around the sun, but it hasn't collected all of the material that was near its position in the disk when it was forming. So there are still some other little debris chunks left around Pluto's orbit, and that means that it's not a full planet anymore.
Yeah. Sorry, buddy.
Yeah. So the IAU went through with that vote, and there was, a very clear winner that the definition should be accepted. This caused a lot of drama in the field. Some people said that the voting wasn't fair because there weren't enough planetary scientists who were present for the vote. So it was, the people making this decision about what a planet should be, they were stars people, they were galaxies people, they were supernovae people who don't deal with planets. So the planet community was understandably a little bit peeved.
Sure.
some said that the definition just didn't make much scientific sense, that it was kind of arbitrary to use these as the criteria for planet, and it seemed like it was just motivated by not wanting to, again, inflate the list of planets in the solar system. But it stuck. It stuck because there was a vote. People didn't want to have to go through the drama of doing it over again. And so now we have this easy delineation between planets and small solar system objects. And that makes things easier for school children, but unfortunately Pluto was the sacrifice in that move.
We had to lose Pluto for everyone to learn.
We did. But that's okay, because we know that here at Pale Blue Pod, Pluto is still special. It's a dwarf planet. Yeah, it's a special planet.
Hi, it's Corinne. Just want to give a quick thanks to our patrons, especially our Sun Lake stars, Scott Reynolds, Augustin, and Tom T. And remember, patrons get to hear their name on the show, make their mark on our patron star chart, and get research notes for every episode, all by supporting us on Patreon for just about $1 per episode. If you sign up for an annual membership, you get a 13% discount. Find the star chart, Patreon info, and more at our website, palebluepod.com, or by going right to patreon.com/palebluepod. And of course, if you can't support us financially, that's totally fine. We love you so much. Thank you for listening. You can support us by reviewing the show on whatever app you use and by sharing the show with your friends. And I also have a show recommendation for you. Big Game Hunger is a weekly comedy show where Jenna Stieber and friends craft the next big video game. Starting with randomly generated genre, concepts, and vibes, Jenna and her funny, game-obsessed guests will take these ideas far enough that they can pitch it to a shadowy board of rich investors. By the end of the episode, they'll have honed an IP so irresistible, you'll be ready to risk $25 for it on Steam. Get ready to laugh about the games you love and learn about game trends and yearn for titles that will surely never make their release date. New episodes every Monday. Okay, back to our show.
Okay, so for some Earth numbies, what you wanted to hear.
Yay!
I'm going to start with the Earth itself and then move to its relationship to the sun and the moon and other things around it. Its mass is 6 times 10 to the 24 kilograms. So that's 6 followed by 24 zeros.
That sounds huge.
It is huge by comparison to us, for sure. But it's quite small by comparison to other things. So I have here that it is 0.3% the mass of Jupiter. That's not 0.3 times. That's 0.3%. It's a very small fraction of Jupiter's mass. And it's 0.0003% of the sun's mass. So in the grand scheme of things, Earth, very tiny.
Yeah, Earth. I've always thought that about Earth. It's too small.
You know, I am inclined to agree with you. This is a tangent. One of my favorite worlds that I built on my other podcast, Exolore, was a world that was so physically large that the transatlantic slave trade never happened just because you couldn't physically cross those distances.
You could never get people over.
Yeah. So I agree. Earth is just too small.
Love it.
To know exactly how small it is, its diameter is about 8,000 miles at the equator, and Earth isn't perfectly spherical. I don't know if you knew that, Corinne.
I did know that. It's a little bit pushed, like on the top and bottom.
Yeah.
Just a little.
Yeah, like someone saw it and they were like, oh, you're so cute. And then they smushed it.
Squish. Yeah.
Yeah, we call this oblate. It is an oblate spheroid, and it's a little squashed because of the Earth's rotation around its axis. And if it were rotating any faster, we would be a little bit more squashed. Or if we were made of, less dense material and it was easier to morph our shape. But yeah, we are not a perfect sphere. Close enough, though.
Good enough in my book.
Mm-hmm. We are 93 million miles away from the sun on average. That is what astronomers call one astronomical unit, but I also have it in some other units for you. If you're not in the good old US of A and you don't use these weird units, it's 150 million kilometers away from the sun. But astronomers, we learn it in a unit that makes no sense. When I was in my early astronomy classes learning about the astronomical unit, they taught it to us in centimeters.
Why that?
Girl, your guess
seems insane.
Your guess is as good as mine. I don't understand it at all. I learned that the distance to the sun is 1.5 times 10 to the 13 centimeter.
That's so weird because it's so tiny.
It's so tiny. I actually do have a reason. So different scientific disciplines have different units that they tend to use, even if you're on the SI system, like even if you're using kilograms versus pounds or whatever. There are specialized units for all scientific disciplines that are just useful for them. And for astronomers, our special units are based on grams, seconds, and centimeters. There are others, like in physics, I remember we mostly used kilograms, meters, and seconds. But for some reason with astronomy, I think because we are used to dealing with very small energies and brightnesses, because we're studying large, powerful things, but they're far away. So we're using, we're like measuring really small brightnesses. So I think we attune our units to that.
Okay, I think that makes sense to me. I can see why we would do that.
Don't give them that credit, Corinne. It doesn't make sense.
I don't love it.
Yeah, so, like the unit that astronomers use for energy is called the erg, E-R-G, and that is some combination of units, but it's based on grams, centimeters, and seconds. So yeah, I learned 1.5 times 10 to the 13 centimeters to the sun. You can also say that it's 8 light minutes from the Earth to the sun. It would take a particle of light 8 minutes to get from the sun to us.
Wow. Yes, that I knew because I feel like that went around when I was in school of like the sun could blow up and we wouldn't know for 8 minutes.
It's true.
Crazy.
The Earth rotates once every 24 hours-ish. It's like 23 hours, 56 minutes, and some number of seconds. But even that isn't exactly the same length every time. And you have to be careful about how you're measuring the length of a day. Are you measuring it from, let's say, like when the Earth is pointing at a particular star in the distance, like a night sky star, back to that? Or do you have to go back to facing the sun? Or is it just like when the sun is at its peak? And if everything were perfect about our orbit, if we were moving on an exactly circular orbit and we were always the same distance from the sun and we were always rotating at the same speed, we would have the same day length every single day. But sometimes Earth is closer to the sun and sometimes it's farther away. And that means we have to like rotate just a little bit more or less for the sun to be in the same place that it was the day before. Because from one day to another, not only are we rotating, but we're moving a little bit around the sun. There are these complicated things. So yes, we say that the Earth's day is 24 hours, but it's a little bit more complicated than that.
Yeah, for sure.
And we are familiar with how the Earth's orbit around the sun doesn't fit into a neat round number because the length of a year here on Earth is 365.2422 days. And that has led to really complicated leap year rules. If it was just 365.25 days, we could do the leap day every 4 years and it would be totally fine.
Yeah.
But nope. It's not that perfect. So instead, we have to do leap year every 4 years, but not when that year is divisible by 100. So, like back in 1900, they didn't have a leap year.
Sure, because it's divisible by 100.
But then the leap day comes back when the year is divisible by 400. So in 2000, we actually did have a leap year.
Right. Yes. Okay.
All because space doesn't owe us neat round numbers.
Yeah. Why? We made numbers up.
Yes. And if we had done a better job, then we could have said
everything would be in alignment.
Yeah. It's our fault. We made math wrong. Yep. The Earth is tilted by about 23.5 degrees, and it currently points towards Polaris. That's our North Star. But we are rotating on this 26,000-year cycle, so eventually Polaris will not be our North Star anymore. And actually 5,000 years ago, it was a different star called Alpha Draconis. sometimes called Thuban. I've never heard of
that
yeah.
one.
Thuban, Thuban. That was our North Star 5,000 years ago. And in 13,000 years, the North Star will be Vega, which is a really, really bright star. So
yes,
things are moving. And I said before that we don't have a perfectly circular orbit. We have what's called an eccentric orbit. So it's a little bit of an oval. Our eccentricity is 0.017, so pretty damn close to circular, but not perfectly. And with that eccentricity, that means that the difference between the Earth's closest approach to the sun and furthest distance from the sun is about 5 million miles.
That's big.
Yes. Way, way bigger than Earth.
Yeah, that's huge.
It's huge. I want to talk a bit about the structure. Mm-hmm. So we have this solid inner core that's about 750 miles in radius, so 1,500 in diameter, and that's at the center of the planet. It's made of iron and nickel, and its temperature is almost 10,000 degrees Fahrenheit.
Mm-hmm.
Quite hot. That is surrounded by an outer liquid core, also made of iron and nickel, and that's about 1,400 miles thick. And we should be really grateful to that moving liquid layer of iron and nickel because that's what gives us our magnetic field. Those interactions of moving electrically charged particles, that gives us our protective magnetic field, which, saves us from the solar wind. It gives us really pretty aurora. Mm-hmm. Sometimes it also can deflect some small rocky bodies. So yeah, thank you.
Yeah, cool.
Magnetic field. The outer core is surrounded by the mantle, which is the thickest part of the Earth. It's about 1,800 miles thick, and it's oozy. It has a consistency like melted plastic, and it is yucky. Yeah. You don't want to find yourself in the mantle.
No. I'll never be there. I'll never go there.
Yes, good. That's wise. It is a molten layer of rock made of the lighter elements that didn't sink to the center when the Earth was forming. And that's why you find the heavier, denser elements in the center, like iron and nickel, and you find the lighter stuff, like all of the silica, all of the quartz, on the surface of Earth, where the crust is. So we have the crust at the very top, and that is the lightest, fluffiest stuff separating us from the mantle. Corinne, how thick do you think that crust is? How much space is between you and that oozing molten layer of rock?
Oh my God, I want to say thousands of miles.
Don't you want to say thousands of miles?
I mean, I'm thinking of volcanoes though, and I am like, well, how deep could that really go? But it's got to be 1,000.
Corinne, it's 20 miles.
No.
Yeah, you're maybe...
It's shorter than running a marathon.
Yes. Yes. You are less than a marathon separated from the mantle of our planet.
Guys, that's really scary. I don't think we should be.
I know, right? I was floored. I was like, no, surely the continent of America is thicker than that.
I do feel like I could do that and that I shouldn't feel like that.
Mm-hmm, mm-hmm. So that's the structure. Hopefully that doesn't give anyone nightmares. But those 20 miles have been holding it strong in most parts of the world. So
that's good. Maybe that's some kind of affirmation of you can give less than you want to give and it'll do the job.
Yeah, I like that. It's a good lesson. We have an atmosphere made of gases. It's a pretty thick atmosphere, a few miles. What's the most abundant gas in our atmosphere, Corinne? Do you know? You might be surprised.
I think I remember it not being oxygen, but I don't remember what it was.
Okay, then you wouldn't be very surprised. It's nitrogen. It's 78% nitrogen.
Yes, I do remember being very surprised when I did learn that because I just assumed it was oxygen because that's how we're all here.
Right, exactly. So currently, it has changed over time, but currently our atmosphere is about 78% nitrogen, 21% oxygen.
Okay.
And that adds up to 99. So everything else is very tiny quantities. It's 0.9% argon.
Okay. I never think about argon.
Never think about argon. We think of everything else before we think of argon, and yet it's number 3.
Carbon dioxide.
Mm-hmm. Yeah.
Other stuff.
Carbon dioxide, water vapor, methane, ethane, ozone, all of that is less than 0.1% of the composition of our atmosphere.
Wow.
Wow. Yeah, and all the other stuff. We have no rings. We were robbed in that respect.
Yeah.
We do have one moon.
Yes.
We know it. We love it. She is about a quarter of Earth's size and most likely formed from an impact with a Mars-sized object early on in our solar system's history called Theia. And the moon is about 240,000 miles away. That's 385,000 kilometers for the rest of the world. And we are the only planet in the solar system known to harbor life. So we are the only known habitable planet, not just in the solar system, but in the universe. Corinne, can you think of some things that make Earth habitable?
Oh, yeah. I mean, we talked about the magnetic field that protects us from solar wind, but we're the right... Well, this is for human life, but like we're the right temperature. We have water. We have oxygen. But really water, at least when I was in elementary school, was like the number one indicator for possibility of life.
Yeah, and that is still the gold standard when astronomers are doing their search for life out there. So you got them. There's water. There's our magnetic field, our moon. A lot of people attribute much of our success to the moon because it creates the tides. And, life formed in the water and something that can mix water, especially at the intersection between the ocean and land. Very valuable. Very, very good at mixing things.
For sure.
And perhaps Jupiter. The jury's still out on this, but some people say that because we have this massive planet, like kind of far away in the solar system, that it takes some of the asteroid and comet hits on our behalf.
Oh, thanks, Jupiter. I never thought of Jupiter as a bodyguard.
A little bit. Although some people say that it flings things our way too. So it might be a wash, but I'd say let's give it to Jupiter.
I'm going to give it the benefit of the doubt.
Yeah, exactly. Exactly. So those are the Earth's characteristics. Many things that we have learned from the surface of Earth, just by being here as people, but also a lot of stuff that we've been able to learn by launching things into space, turning them around, and studying Earth as a planet the way we do any other planet out in the universe. And so NASA has been studying Earth since its inception, since it was founded, when we were deep in the space race and people were putting up satellites into space. Those satellites were not originally supposed to be studying distant things in the universe. They were turned around. They were looking at Earth. So the earliest satellites were looking at things like weather and cloud coverage, and I'm sure there was some spying. Probably. I don't know.
Oh, yeah.
Yeah.
I don't doubt it.
Like, almost certainly. But the public stuff, it was all about weather and cloud coverage. On April 1st, a bold day to launch a spacecraft, but on April 1st, 1960...
That reminds me, though, I wore weird earrings to school on April 1st in middle school because I was like, well, if anyone makes fun of me, I'll just say it's for April Fools.
Brilliant.
So if this mission goes wrong, you could have just said April Fools.
Oops. Psych.
Yeah.
So it was their big April Fool's joke to launch TIROS-1. And it never even occurred to me to look up what that stands for, but it is an acronym because it's all capitalized. So if I had to guess, I would say that it stands for the Interspatial Radio Observatory for Science.
I think that's perfect.
Yes. So it was launched in 1960 to monitor weather. It operated for 78 days and provided the first space-based accurate weather forecasts.
Okay. I didn't think of accurate weather forecasts as being that recent.
Oh, they were doing accurate weather forecasts before that, but they didn't have space data. So this was
data.
Like, can we also predict things from the other side of what's happening?
Wow, that's so cool.
In 1964, NASA launched Nimbus, which is not an acronym.
Okay, just a cute reference.
Yes.
Yeah.
So Nimbus was 30 satellites that were launched in 1964 to monitor cloud coverage. It took the first hurricane images from space. It actually helped with some search and rescue technology development.
I love that.
And it measured ocean plant life and the ozone layer. So probably one of the things responsible for that big, like, there's a hole in the ozone layer.
Yes.
We ought to do something about it.
100%.
Yes.
Yeah.
So thank you.
Wow, that was scary.
In 1999, NASA launched the NASA's Earth Observatory, and that was meant to study a lot of weather patterns and like biological life and stuff like that, whatever they could see from space. So we had NASA's Earth Observatory in 1999, and now NASA is getting ready to launch a whole new observatory in 2029 to be the follow-up. It's going to be called NASA's Earth System Observatory, very similar, and it's going to study similar things. And it's going to be working closely with NASA's very exciting Earth Sciences Division. This is a whole branch of NASA that is dedicated to understanding Earth as a planet from space and from the ground. And they have identified 6 different key research areas. Those are atmospheric composition. So they're studying this both chemically and physically, what's going on in the atmosphere. How does energy get transferred across our atmosphere? And what is the air quality? How does that change over time? That's all one branch.
To know.
And then they have a research area for weather and atmospheric dynamics. So not what is the air made of, but how is it moving and changing over time? Because the transport of heat and moisture through our atmosphere is basically what makes our weather.
Yeah.
Then they have a research area on climate variability and change. Self-explanatory. They have one for water and the energy cycle, which is also pretty self-explanatory. They have one for carbon cycle and ecosystems, which is, in my opinion, a very large category. It looks at changing ecosystems, what they call biogeochemical cycles, biodiversity. So really anything where Earth is interacting with life on it, that's what they're studying in that division.
Easy enough.
And then they have a research area for Earth's surface and interior. So all the inside stuff with geophysics and seismology. And that's how they're studying the Earth.
Thank you, NASA.
Thanks, NASA. And of course, other space agencies around the world are studying Earth. It's just very easy for me to learn about what NASA is doing compared to other agencies. But yeah, hopefully we'll learn cool stuff about Earth soon. You know, we still have this weird magnetic field that we don't totally understand. We don't totally understand how earthquakes start. There's so much that we still need to know about Earth, whether it's slowing down or speeding up in its spinning. So yeah, we will hopefully have those answers soon.
Yay.
Any lingering questions about Earth?
Not many. It's funny to hear it in context of other planets. It feels a lot smaller, but when you are living on it, it feels so big.
It does feel big. That's because it is big compared to us. We are very small.
Compared to us. I am just a girl.
Yes, we're just girls. So we've now covered all of the planets in the solar system, Corinne, and I feel like it would be good to somehow arrange them according to like a personality indicator or something. Is there such a personality indicator that you would like to use? We could do Myers-Briggs. We could do Enneagrams. What's calling to you?
I want to use an alignment chart. I want to use the lawful, true, chaotic.
Yes. Okay. So for anyone who's played a role-playing game like D&D before, when you have to decide the morality of your character and place it onto this chart, we're going to do that for each of the planets in the solar system. Now, this alignment chart, it's 3 by 3, and on the top it goes from lawful to neutral to chaotic.
Yep. So, and then top column's good, middle column's neutral, bottom is evil.
Yes. So lawful, neutral, chaotic, and good, neutral, evil. Those are the axes of this graph. Let's go in order of the planets, Corinne, and start with Mercury. It's the small one. It moves really fast. It doesn't have much of an atmosphere, doesn't have any moons, couldn't hold on to them.
That's so challenging for me. I think Mercury is... I'm sorry, but I think Mercury is evil.
Ooh, okay. I'm here for it.
It just feels a little bit sneaky and weird.
Does it feel lawful or chaotic in its evilness?
I think it might be neutral.
I agree 100%. Yeah. Okay, so Mercury, we're saying, is neutral evil. What about Venus?
Okay, Venus is good to me. Venus is a lawful good.
Oh, Venus is the lawful good planet in our solar system, you think? It's your alignment chart, Corinne.
Or is that where Earth should be? I feel like Earth is... I'm not good at these alignment charts. I just think they're fun. I think that Earth is either lawful good or chaotic good. Maybe that means it's a neutral good.
Yeah, I think if you can't choose, then it's in the middle.
Yeah.
So we're saying neutral good.
Is Earth.
Is Earth. Okay. So Venus lawful
insane?
Good, Earth neutral good. Can you explain yourself? Especially on Venus. I would love to know your thoughts on Venus.
Venus, to me, I'm not even associating with Venus's qualities. I'm associating it from the very outdated self-help book of men are from Mars, women are from Venus.
And women are lawful good.
Women are lawful good.
Okay, so nothing about the hazy atmosphere so hot that it could melt lead. Nothing about the toxic fumes in the atmosphere.
I guess I feel like other planets are more evil than that.
All right. Okay. Moving on to Mars. Where is Mars in the chart?
Mars is... That's challenging because I think Mars is good vibes, but I don't like everyone who's trying to get there.
Yeah. Well, that's not Mars's fault that people are trying to reach it.
No, it's true. Wow, this is going to be the most chaotic, evil alignment chart of all time. I feel like Mars is maybe... Is Mars neutral?
Like
Mars
true
good?
neutral?
Maybe not true neutral, but like...
Okay. But like lawful or chaotic neutral?
Yeah. Chaotic.
Chaotic neutral for Mars. I think that tracks. Because the chaos of people wanting to go there, but the neutrality of it not being Mars's fault.
Yeah, that's what I'm thinking.
Mm-hmm. Next, we're going on to Jupiter.
I'm just trying to go off gut here to keep it to keep it quick. Jupiter is chaotic good.
Yeah, because as we've just discussed, it could be holding back a lot of asteroids for us, but it could also be sending us some every once in a while. Mm-hmm.
Yes.
Okay, that makes sense. Saturn.
Saturn is... What do I have open? I have lawful, evil...
You
I
have
all the lawful and neutral evil.
Lawful, neutral, evil. You have true neutral, and you have chaotic evil left.
Okay, I kind of think Pluto's true neutral.
That's a wild choice to me.
Because it's not even really part of this.
It's the Switzerland. It's like,
yes,
I'm going to be here when you planets figure out your mess. Just come to me when you're ready.
Exactly.
Okay, true neutral Pluto.
So then Saturn, Uranus, and Neptune are left. Who's evil in that group?
I don't know if it's just because I wasn't popular in high school, but I feel like Saturn is a popular mean girl.
I agree with that. I'm in. Mm-hmm. So
evil, lawful or chaotic?
Saturn is chaotic evil to me.
Hell yeah, I'm inclined to agree. So now we have lawful, neutral, and evil, and we have to split them between Neptune and Uranus.
I think Uranus is lawful, neutral. Ooh, but people like to use the name as a joke.
They do.
So maybe lawful evil.
Okay.
And then Neptune, lawful neutral.
Yeah.
Wow.
Because Neptune is not offensive at all. It's there. It's just doing its thing.
It's trying its best.
With its watery moons.
I am sure that I'm going to look at this chart in 10 minutes and think this was an insane choice that I've made, but I stand by it for now.
You started off so bold, you could only get a little bit more unhinged from there, and I think you nailed it.
And these charts were meant to be fun.
Yeah, exactly. Well, good job.
Thanks.
Corinne, I've actually been looking back through our episodes, and with this last test of the alignment chart, you've actually achieved enough credits to graduate from our pale blue Podiversity, pending you pass your final exam.
Okay, yes, there is a final exam. I'm going to try really hard.
Corinne, you are our top pupil. You are our star student. So I don't think you're going to struggle at all. But,
thank you.
You are on track to graduate soon. So.
Yes, it's true. I will be graduating from the podcast on episode 100. So we're not quite there yet.
No.
You get a little bit more time. But I am so excited to be approaching graduation and so grateful for the listeners and for you, Moiya. And I promise to study hard for this final exam.
Good. Yes, you're not done yet, but we can get you some s'mores. We can heat up some goodies on a fire and use that to fuel our studying.
I can't wait. That's going to be the best study session I've ever had, probably.
Love it. Well, no matter how you like your marshmallows, although I am partial to just like a slight golden brown.
Oh, I scorch them.
Really?
Yeah. Oh. I love them like black and cancer causing.
Wow.
Love it.
See, and we are both space, and so are you. Bye. Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.